Case study number 2, reduce compressor duty cycling. Compressor cycling or duty cycling in a single unit can be detrimental to the mechanical equipment and could cause compressor failure. When WSCO is managing the cooling, we call for equipment to run more often with the full cooling capacity of both compressors in operation. When we recognize a unit does not have a good delta T across the supply and return air temperatures, the individual unit may be heating the space, as that may be operating on fan only or only one compressor. This competes then with the other crack units in the space. Working with this customer, we found several units had poor delta T across the supply and return. By adjusting the configuration settings, we allow both compressors to be engaged, providing various operational benefits. Number 1, it extends the compressor life. 2, it reduces maintenance and avoids replacement costs, with the average compressor costing $7,000. And lastly, number 3, it improves the cooling capacity from the unit. This allows the system to learn new configurations for the equipment to operate and maintain desired temperatures. This customer was performing daily reviews of cooling equipment and noticed that one of their crack units was underperforming. They went to the unit in question and reviewed the historical data. The yellow line indicates when the cooling unit is running. The blue line shows the instantaneous power consumption, and the red line is the return air temperature. The customer trended several days of data and noticed something strange about the unit's power consumption. What we expect to see is that when the cooling unit is running, its power usage holds steady. That's what's happening on the right side of the graph. But on the left side, you can see that the power usage is vacillating between a high of 36.1 kW here and a low of 19.5 kW here. There are even a couple of instances when the power drops all the way down to 1.5 kW even though the unit is running. So what's going on? If we look at the return air temperature trend line, we see that it's hovering around 71 degrees and the power is fluctuating. Whereas when the return air temperature is above 71 degrees over here, the power usage is holding steady. After the set point change on September 23rd, what we see now is that anytime the unit is operating, the power of the unit is consistently at about 36 kW. That means the compressor is no longer duty cycling even when the return air temperature drops well below the 70 degrees. This is one example of how a customer leveraged the data collected from their investment in WSCO to improve equipment performance and reduce maintenance costs.